Hello everyone, welcome to Math Top Grades or Math Top G as I like to call it. Inshallah, today we are going to talk about sequences, linear sequences, quadratic sequences, cubic sequences, and also Fibonacci sequence. So let's start here with the first type of sequences which we have, which is linear sequence. Linear, how can we know if the sequence is linear or not? We know that if you are adding this or subtracting the same number. For example, here, this one, each one here, you are adding 1.5. Okay, each one to move from term to the other, you are adding 1.5. First thing you have to know about that is how to find the nth term of linear sequence. Since you know you are adding 1.5, so simply you can write 1.5 n, and then you subtract the first term, which is 5.5 minus 1.5. Okay, minus 1.5 here. So 5.5 minus 1.5, it will be positive 4, so plus 4, which means the nth term of the sequence here is 1.5 n plus 4, or if you want to write it as a decimal, 1.5 n plus 4. And this nth term here actually is very useful because you are going to use it to solve next questions. Work out the 100th term. So all you have to do here is just substitute n here with 100. So 1.5 multiplied by 100 and then plus 4. And here the answer is going to be 154. Question C is 98.5 is a term in this sequence or not, and give a reason for your decision. To do that, to know if this is a term in the sequence or not, you have to get your nth term, which is 1.5 n plus 4, and make it equal 98.5. And then you solve the equation. All you have to do here after solving the equation, you have to know that this n must be a positive integer. Okay? N must be a positive what? Integer. If n is a decimal or a negative number, so in this case, the answer will be no. If n is a positive integer, so the answer will be yes. Let's solve this equation here. So 1.5n equals 98.5 minus 4, so it's going to be 94.5. Divide by 1.5 in both sides. So in this case, n equals 63. And since n is a positive integer here, so the answer is going to be yes. 98.5 is a term in this sequence. Question D here, which term of this sequence is equal to 100? Which means you will do the same exact thing, but you know that n here must be also a positive integer, and it will be when you do that. You get the nth term here, which is 1.5n plus 4, and make it equal 100, and then solve the equation to get which term is going to has a value of 100. So 1.5n equals 96, then over 1.5 over 1.5. So in this case, n equals 64. So the 64th term has a value of 100. If you take a look at this question here, you will find out that each time we are subtracting the same number. If you take a look here, this is minus 6, here is also minus 6, and here minus 6. So this is an arithmetic sequence or linear sequence. Find out the next term, so simply you will subtract another 6, so 5 minus 6 equals negative 1. So this is the next term. Find the nth term. To find the nth term of the sequence, we are going to use it the same way we did before. We are subtracting 6 every time, so I'm going to write negative 6n, and I'm going to subtract the first term minus the common difference which we are subtracting every time. So 23 minus negative 6 is going to be 29. So here negative 6n plus 29, this is your nth term. And you can check if your answer correct or not easily by substituting n here with 1, you will get 23. If you substitute n with 2, you will get 17, and so on. That's how you know if your answer correct or not. You may be asked some other questions like the previous one. Find, for example, the 50th term. Is this a term in the sequence or not? You will use the same methods we used in the previous example. Now, let's enter the world of geometric sequence here. Unlike the arithmetic sequence or linear sequence, we are not adding the same amount every time we are multiplying. If you take a look here, 2 became 6, 6 became 18, and 18 became 54. Obviously, we are not adding the same amount here. We are multiplying. So it's multiplying by 3. To write the nth term of each sequence, since you notice and you observe that it is a geometric sequence, you have to know the general term of geometric sequence, which is a multiply r power of n minus 1, which a here is the first term and r here is the common ratio. Okay. Let's simply substitute a in the first term. Our first term here is 2, so I'm going to write 2. R is the common ratio, which is the number we are multiplying every time. So 3, and here 3 power of n minus 1. And this is the nth term you can use to find any term in this geometric sequence. Let's take a look at the second question here. Every time, what's happening? Okay, mister, you will say 60 became 30, 30 became 15, 15 becomes 7.5. Okay, mister, we are dividing by 2. Yes, you are dividing by 2, but you have to know the common ratio, which means you are multiplying by what, not dividing by what. Here, instead of saying dividing by 2, you will say multiply by half, because multiplying by half is the same as dividing by 2. Then we are going to use the same general term we used in the previous question. Here, the first term is 60, so I'm going to write 60. Multiply the common ratio, which we are multiplying by half, so I'm going to write half power of n minus 1, and this will be the nth term in this sequence, for this sequence. Let's talk together about quadratic sequence. And the first thing is, how can you know if you are dealing with quadratic sequence or not? So first of all, you are checking the difference between the terms. So here this is plus 9, here plus 15, and here plus 21, plus 27. Obviously, we are not adding the same number every time, so we are going to check the second difference, which is the difference between differences. Here, this is plus 6, and here also plus 6. Now, in this case, you know clearly that for sure that you are dealing with quadratic sequence. To solve quadratic sequence, it must be in this form. an squared plus bn plus c. N is because it's nth term, and your job is to get the value of a, value of b, and the value of c. How can we get all of that? First of all, we are going to start from here. The second difference is always 2a. What is the second difference here? The second difference is 6. So in this case, 2a equals 6, and in this case a equals 3. So now we got the value of a, which is the coefficient of n squared. The first difference which we have here, which is 9, this is equal to 3a plus b. So 3a plus b equals 9, We got the value of A before, which is 3. Simply substitute here. Is going to be 3 multiplied 3 is 9. So 9 plus B equals 9. And in this case, B equals 0. Okay. Now let's get the value of C. How can we get the value of C? A plus B plus C equal always the first term. So A plus B plus C equal the first term of the sequence itself, which is 11. And now A is 3 plus B, which is 0, plus C equals 11. And in this case, C equals 8. Now our nth term here, we will substitute in this formula here, as I told you. So A is 3, so 3n squared. B is 0, so we can simply ignore this term, plus C, which is 8, and this is your nth term for this quadratic sequence. You can check your answer by substituting n with 1 to get the first term, n with 2, n with 3. You can simply check your answer for this. Now, let's talk about cubic sequence. How can you know if your sequence is cubic or not? And what is the nth term of cubic sequence? We will cover that now. This is the nth term of any cubic sequence, and similar to the quadratic sequence, you have to get the value of A, B, C, and D using these equations here. Now, how can you know, how can you recognize, how can you realize that your sequence here is cubic or not? First, as usual, you are getting the differences between these terms over here. So here the difference is 1, you are adding 1. Here you are adding 7, plus 19, and here plus 37. Let's get the second difference here. So this is plus 6, plus 12, and here this is plus 18. As you can see, the second difference is not the same, so let's get the third difference. So here the third difference is plus 6, and here also plus 6. If the third difference here is the same, so that means you are dealing with cubic sequence. And to get the value of A, B, C, and D, you will use these equations. Let's start here. The first one we have is A, 6A equals the third difference, which is what? Which is 6. And now simply you can divide by 6 in both sides. So A equals 1, and this is the value of A. To get the value of B, you will use the second equation here, which is 12A plus 2B equal the second difference, which is positive 6. And now simply you can just substitute A with 1, because we found it here with 1. So 12 plus 2B equals 6. And when you solve this equation here, B will equal to negative 3. Now you have the value of A and the value of B. Let's get the value of C using the third equation which we have here. Now 7A plus 3B, 7A plus 3B plus C equals difference between the first two terms, which is this, which is equal 1. Substitute the values of A and B because we got them before. So A equals 1, so this is 7, plus 3 multiply negative 3, plus C equals 1. And after that, when you solve this equation, C will equal to 3. Let's use the fourth equation here to get the value of D. Always the fourth equation or the last equation we are going to use, that A plus B plus C plus D equal the first term. So here A plus B plus C plus D equals the first term of our sequence here, which is negative 1. A is 1 plus B is negative 3 plus C, which is 3 plus D equals 1. And when you solve this equation here, the value of D will equal to negative 2. Khalas, now we have the value of A, B, C, and D. Let's substitute in the equation we have up here, and then you will get the nth term. So the nth term is going to be n cubed minus 3n squared plus 3n minus 2, and you can check if it's correct or not by substituting n with 1, you will get the first term, substitute n with 2, you will get the second term, and so on. Now let's talk about Fibonacci sequence. In Fibonacci sequence here, as mentioned, after the first two terms, the rule is to add the previous two terms to find the next term. What that means, after this term and that term, we got 2. How did we get this 2? By adding 1 plus 1. How can we get the term after that? By adding these two terms. 1 plus 2 equals 3. How can we get 5? By adding 3 plus 2, and so on. Now, this question here, write down the next two terms in this sequence. So to get this term over here, we add 13 plus 8. So 13 plus 8 is 21. And to get the term after that, we simply add 21 and 13. So 21 plus 13 equals 34. As mentioned here, all of the following are Fibonacci sequence. It's not written Fibonacci, but this is the definition of Fibonacci sequence, which is what? To get the term, you add the previous two terms. Write down the first two terms in this sequence. How can we get this and how can we get that? We can get this term first by subtracting 11 minus 3. 11 minus 3 is 8. And we can get this term by subtracting 3 minus 8 equals negative 5. Over here, you can check your answer easily by adding each two terms, and you have to get the term after that, which means here, negative 5 plus 8 gives you 3. 8 plus 3 equals 11. So now negative 5 and 8 are reasonable answers. This is the answer of question B. In question C here, find the value of D and the value of E. Okay, let's talk about that. You know this is Fibonacci sequence, which means 2 plus D equals E. Okay, 2 plus D equals E. And here, D plus E must give you 10. So here, D plus E equals 10. And now you have two equations in two variables. You can simply solve them simultaneously by putting them on top of each other. But first, you have to arrange them, getting D and E on the same side. So I'm going to move this here. I will have E minus D equals 2. And let's rearrange this. E plus D equals 10. You can solve this equation here by elimination. If you add the two equations here, this will be cancelled. So 2E equals 12. And in this case, E equals what? 6. Substitute in any equation of the ones you have here. Any one of the four equations will work. So 2 plus D equals E. 2 plus D equals 6. And now the value of D equals 4. You can check your answer here by writing the sequence again. 2, 4, 6, and 10. 2 plus 4 equals 6, and 4 plus 6 equals 10. So that means we got the answer correctly. Now let's talk about that. Find the values of x, y, and z. This idea here is very much similar to the one before, but in 3 variables. So let's form our equations and let's see how can we solve a system of equations in 3 variables. We know negative 33 plus x must give you y, so let's write that down. Negative 33 plus x equals y. X plus y equals z. So x plus y equals z. Y plus z equals 18. Y plus Z equals 18. You will tell me, Mr. Okay, we know about how to solve equations in two variables. Here we have three variables. What should we do? Here you have to get to one variable in term of the other. This equation here, the first one, is in terms of x and y. So, and this is x and y. Your problem, Mr., we have z here. So let's get z as a subject, then substitute. And what I mean here is just move this here. So from that you can say that z equals 18 minus y. Substitute with this equation in this instead of this z. We will have that x plus y equals 18 minus y, which means instead of this z, we wrote its value here, which is 18 minus y. Move this y here, so x plus 2y equals 18. Write the first equation here, but you have to rearrange it first. Here, negative 33 plus x equals y. So now we can simply say that x minus y equals positive 33 after manipulating this equation. And now let's subtract these two equations here to get rid of x, to eliminate x from our equation. So this will be cancelled. 2y minus negative y is going to be 3y. 3y equals 18 minus 33 is going to be negative 15. In this case, y equals negative 5. We got the value of y. Let's check any equation here which to get the value of x. Let's check this one, for example. So x plus y, which means plus negative 5. And this one here has z, so we can't do that. We got the value of x of y. We got the we got the value of y. So let's substitute in the first equation to get the value of x. So negative 33 plus x equals negative 5, and in this case x equals 28. We can substitute here, or you can substitute here x plus y equals z, x plus y equals z, okay? X equals 28 plus y equals negative 5. So this is equals z, and in this case z equals in 28 plus negative 5 is going to be positive 23. You got the values of x, y, and z. Of course, you will always have doubts. So write the sequence in front of you. So negative 33, x is 28, x is 28, and then y is negative 5. Z is 23, and then 18. Add each two terms. You must get the term after that. Add each two terms. You will get the term after that, and so on. And this was Fibonacci sequence in brief. Let's take a look at this. Here, if you try to get the common difference between these fractions, you will find weird numbers. Okay, the common technique to solve this kind of questions is to deal with numerators as a sequence and with denominators as another sequence. If you take a look here, 1, 2, 3, 4, 5, so the common difference is 1. So up here is 1n, and if you substitute here 1 minus 1, as I taught you at the beginning of this video, so it's going to be the same. That's why the nth term of numerators is n over. When you do that here, check the common difference between denominators. The common difference is 1, so you are going to write n, and now it's 1n as I taught you, so 3 minus 1 is 2, so that's n plus 2, and this is the nth term of the sequence here, n over n plus 2. I hope you liked that video. If you liked it, please press like and subscribe and turn on notifications to get more videos. Thank you very much for watching and have a nice day.